Okay, so the last video got cut off kind of abruptly, but hopefully you found your way back to this one, and we are going to do these last three problems now. So when you see the words factor completely, when you see that completely in there, often that is a little clue that there might be more than one step. Okay, so we want to factor not just the first step, but all the way until there's no more chance to factor anything else. All right, so we have these two terms here, and we want to remember those steps that we had up above. So the first thing we're always going to do is look for a GCF. And if I look at these two, they do have a greatest common factor of 5x. So I'm just going to first just pull out the GCF. I don't ever want to do two steps at once, like try to pull it out and factor the rest. I'm just going to pull the GCF out. So 5x cubed, I took out a 5x, I'm left with x squared. 45 divided by 5, negative here, is negative 9. And there's no x left because I took that out. Remember, if you want, you can think of it like this. You could say like it's negative 45x divided by 5x, right? See what you get. Okay, now I look at what I have here. So if I'm looking at these steps that I had up above, I factored out the GCF. Now I want to look at the remaining polynomial and see if it's in the format where I can factor it. So I see that I have two terms here. They are both perfect squares and they're being subtracted. So in this case, I have the difference of perfect squares. So I have to bring my 5x with me. I can't leave that behind because in order to multiply to get what we originally started with, I need to keep that 5x. Now I can factor this though. Difference of perfect squares. Remember, the square root of the first term goes here and here. Square root of the second term goes here and here. Okay, different signs. So there is my polynomial factored completely. When I get to this point, there's no way to factor these further, right? There's nothing that goes into both of them. They're not in any format that we've talked about. So I'm just done here. If you stopped here at this point and didn't think to factor this more, you would get partial credit, but not full credit until you factored it completely. Okay, let's look at the next one. So again, I'm going to look for a GCF. I know that 4 goes into 4 and 8 and 36. We might not be sure about 72, but you can try it and see. And if we do that, remember to do that, we would just take 72 and divide it by 4. And we do get a whole number for that. With the negative, it would be an integer, it'd be negative 18. So 4 does go into all four of these terms, and also x goes into those, okay? So I'm going to take out a 4x, just x to the first power, because that's all I have here, and I'm just going to take out that GCF first. And remember that when I take out a GCF, every term here needs to contribute a term in the parentheses. So 4x to the fourth, I had take out the 4x, and I get x to the third. Then 8x cubed, dividing out the 4x, I get 2x squared. And then I get negative 36 divided by 4 is negative 9, and then x. And then negative 72x divided by 4x is plus 18. Okay, so I've pulled out my GCF. I have something left here. I kind of go through and check. You can see that there's no common factor. Again, I did pull out the biggest one. Remember that if I pull out a smaller one, let's pretend I pulled out 2 by mistake. That's also a common factor, but not the largest. What would happen is that I'd still be able to pull another 2 out of all of these. But I can see that they don't have anything in common. I can't take out an x because this term doesn't have an x. And this only has a 1, so I can't take out a number. So now I do have 4 terms. So I know that if I want to go any further, it has to be a situation where I can factor by grouping. So let's see if that's going to work. So I'm going to look at these two and I'm going to look at these two. Okay, remember I want to put this extra bracket there to kind of show that all of this, there's going to be a minus in the middle, all of that is being multiplied by 4x. So these two, what these two have in common is x squared. And remember, right now I'm forgetting that these exist. I'm only looking at these two, pulling out their greatest common factor, which is x squared, and then what's left is x plus 2. And then for these two, I pull out minus 9, and then I have x, remember 18, let's see here. Oh, this is a minus, that's why. Something didn't look right there. Okay, so here this should be a minus 18 because I took that out there. So you can kind of check your old mistakes in this next step there. So I took out a negative 9 and I get x plus 2. Okay, negative divided by negative is a positive. Okay, so now, still bringing this 4x. Remember now that we look here and we say, okay, what do these two have in common? They have an x plus 2 in common, and then an x squared minus 9, right? X squared minus 9. Let me go over those so they're a little easier to see. Now, why do I not need that extra bracket here? Well, it's because these are all being multiplied, right? These three things, this, or four things, if you want to think about the 4 times the x separately. They're all being multiplied. I don't need to distribute through anything at this point. So I can show that these are all being multiplied. Now, we've done 2 steps so far, right? We pulled out the GCF and then this kind of together was factoring by grouping. If you notice that what we have here, this guy right here can be factored more. That's difference of perfect squares. So I'm going to take my whole answer up here, do 4x times x plus 2, x squared minus 9 again is going to be x plus 3, x minus 3. Now I have factored this completely. None of those factors, none of the things in parentheses can be broken down anymore. Okay, last one. So if I look at this for looking at GCF, there's no x that I can pull out. If I think about 15, factors of 15 are 1 and 15, 3 and 5. Forget 26 for now. Let's go to 8 because that's an easy one to know the factors of, right? 1 times 8, 2 times 4. Just from these two, the only thing they have in common is 1. So even if 26 had something in common with one of them, which it would have 2, we can't do anything because there's nothing that all 3 are going to have in common other than 1. 1 doesn't really help us. Okay, so no GCF, that means this is one of those harder trinomials. So we're going to use the AC method. So A in this case is 15, B is 26, and C is 8. So my AC, or my 15 times 8, is going to be 120. So I need two numbers that are going to multiply to 120 and add up to B, which is 26. So let's think about numbers that multiply 120. And if you notice, they're both positive. So that's a little bit easier. That means all of our signs are going to be positive. So 1 and 120, and again, I don't expect you to know all these off the top of your head, but you can take 120, divide it by 2, see what you get. 120 divided by 3 is 40. 120 divided by 4 is 30. 120 divided by 5 is 24. 120 divided by 6 is 20. 120 divided by 7 is going to give us a decimal, so we're not going to include it. 120 divided by 8 is 15. 120 divided by 9 would also give me a decimal. 120 divided by 10 is 12. And 120 divided by 11 would give me a decimal, and then I'm back to repeating. So these are all the pairs that would multiply to be 120. Now we want a set of numbers that also adds up to 26. So for example, 1 and 120 would add up to 121, right? These would add up to 62. These would add up to 43. We can see that this is our pair of numbers that adds up to 26. Now, remember, these do not go into the binomials, into the parentheses for a harder trinomial. So we have to do that step where we take what we had originally for our polynomial and we split that middle term into 2 terms using the numbers we just found. Okay, so 15x squared plus 6x plus 20x plus 8. So now I'm going to use factoring by grouping. So I have 15x squared plus 6x. What they have in common is going to be 3x, and what they have left over there is 5x plus 2. Plus, bring that plus down because this is positive, the biggest thing that goes into both of those is 4. And I'm going to be left with 5x plus 2. Okay, factoring by grouping, factoring by grouping uses the GCF, factoring out the GCF. So this pulling out the GCF part, I'm going a little bit faster on now. If you need some more help with that, make sure you contact me, okay? Try some more examples, contact me, we can do some together. At this point, as I said, I always like to double check my answer by multiplying back. So 3x times 5x would be 15x squared. This would give me 6x. Here's 20x and here's 8. I can see that they have something in common, which is good. So I have 5x plus 2 times 3x plus 4. Okay, I'm going to know then that that is my answer. If I want to check it, 5x times 3x gives me 15x squared. 5x plus 4, or sorry, 5x times 4 is plus 20x. 2 times 3x is plus 6x. 2 times 4 is plus 8. These would combine to give me that 26 in the middle. All right, so we've gone over a bunch of different kinds of factoring now, right? We started out with factoring out the GCF. Then we talked about trinomials. I'm just going to go up here so you can kind of see. We factor out the GCF. Then we talked about trinomials. We talked about difference of perfect squares. And we talked about factoring by grouping. So what you need to do, again, is to factor out a GCF if you can, and then look at what you have and move it into one of these categories. And if it doesn't go into any of those categories, then you can't do anything else with it. So for example, if you have something like this, if you have, 20x to the fifth, y to the third, minus 5x y squared, okay? I look at this I look for a GCF here. I pull out a 5xy squared. I'm left with a 4x to the fourth y minus 1. Now this almost would be difference of perfect squares, right? 4 is a perfect square, 1's a perfect square, x to the fourth is a perfect square, y to the first is not. I would have to stop at this point because there's nothing else I can do. What I have here does not fit into a pattern of one of these things that I can factor or that I know how to factor. So now if this were y squared, we could do difference of perfect squares, okay? But if you end up with something that does not fit into one of those, then you're just done at that point, and that's okay. All right, if you have any questions, please make sure you ask. Come to office hours, send me a message, send me a message on email or on Teams. Either one is fine. And I will talk to you guys later. Thanks.